Hello and welcome to Clear Water Quality. In this video, I'm going to show an example of precipitation in a simple solution in order to demonstrate the phenomenon of precipitation. So we're using a simple example here of silver chloride that can dissolve into water, and we want to calculate the solubility limit. So for this problem, I've shown the reaction for silver chloride, the precipitation dissolution reaction, and I've identified the KSL value of 10 to the minus 10 that I got from table 6.1 in the textbook Snow, Yank, and Jenkins. So we want to find the solubility of silver chloride. We'll find that first in deionized water, then in a chloride solution, and then we'll solve for the precipitation of the silver chloride solid in a solution where the chloride and the silver are added separately. First of all, we need to consider what solubility is. So it's the amount of ions that will dissolve into a solution, and this won't include any pre-existing ions, so it's just what gets added to the solution. So we want to solve for silver chloride solubility, and we're going to do that here. And one thing to note is that the solubility of silver chloride is going to be equal to the silver ions in the deionized water and also equal to the chloride ions. The reason that they're equal is because they're being added at the same rate since they're being added as silver chloride. So let's consider what this would look like. I'm going to draw a simple schematic of a beaker, and this is DI water, so it doesn't have any pre-existing silver. Put a knot, silver, initial chloride. They're both 0. But some time period later, in the same beaker, we're going to add silver chloride solid, and we'll have some silver and chloride, and they will be equal. Okay, so let me switch to my blue color. To solve this problem, I'm going to use the equilibrium constant and write out a mass action equation. That looks like this. I have the KSO is equal to the product of the silver and chloride ion concentrations, and the silver chloride solid doesn't show up in this equation because it's a solid and solids are 1. Because the silver and the chloride are equal, I can replace the chloride with the silver, and my silver chloride squared is equal to the KSO. Then with that, my solubility, and I'll call it S here, or silver concentration, is equal to the square root of the KSO, and that was 10 to the minus 10. So I have 10 to the minus 5 molar concentration, and that is my solubility limit in DI water. In the next video, I'll show the solution in a chloride solution.